Hello and welcome to another video tutorial on how to use C++. Today we'll cover the topic of variables, because when we are programming we need to access and save the values that we use. And to do that we'll open Visual Studio again, and we want to create a new project. So make sure that Visual C++ and Win32 is selected, and then you can choose a name. In this case I'll choose variables. Click next, make sure this is selected and that we want to have an empty project. So complete. Then here's our project, and now we don't want to add a new element but an existing element, because we want to continue working with our code from last time. And that is the hello world code, which we find here. And we can open this, and I want to change the name, because we want to continue working with this, to main. So last time we output hello world, and we did this all last time, but today we don't want to say hello world, but we want to output different variables. And in C++ we have different sorts of variables. So for example, we have integers for integer numbers, so int, and we also have floats, so floating point numbers. We have doubles, which are also floating numbers but with a bigger range of values. And we have chars, so for characters, and we have strings. And lastly we have booleans, or short bools. This is just to say true or false, or 1 or 0. But first things first, so we have the integer value, which is often used as a counting variable. So for example, if we want to count until 1000, then we can do this with an integer, for example, within a loop. Now how do we introduce a variable? So first we'll type in the data type, so integer, int, and then the name, for example x, and a semicolon. And this part is called the declaration. So now the memory knows that we have a variable called x, which is an integer. Next we have to initialize our value by entering a certain value, for example 4, and a semicolon. So this part is called initialization, but we can also combine the declaration and initialization by just entering, so for example int y equals 5 semicolon. So this is then declaration and initialization. To demonstrate that this all works, I'll just output our variable x by just changing our hello world into the variable's name. And now if we run this, then you see that the output is 4, just as we initialized our x. This can also be done for the y variable, so here we have a 5, and we also can calculate stuff by just entering integer, a new one, named z equals x plus y, semicolon, and then just put z into the output, and you'll see that the output is 9. So these are integer values. But why do we differentiate between integer values, float values, doubles, and so on? Well, the answer is we have to keep the memory in mind when using C++, because an integer value needs less memory than float values, for example. Now I want to request the memory that is used for a variable. So for this we want to output size of an integer value, so an int, And to arrange it better, I'll type in a tab here. But of course we have to put this in quotation marks, so one in front and one in the back. And then there's this command called size of. So we'll type in size of int. And then the unit for this command is byte, so we'll enter here byte. And now if we run this, then we see how much memory is used for an int. So just let's run this, and we see it is 4 byte. I don't want to go into detail here, but you see that in C++ you always have to think of the data type that you want to use and also the range of values if this is sufficient. Because with these 4 bytes we have in the integer value, you cannot count until infinite numbers, but you have to think of if this is enough. And to see this, we can include a file named limits.h. And this file contains values like int min and int max. And we can output these by just using the printf function to see the minimum and maximum value of our integer. So we just type in printf of then text range of value for int from %d to %d. And now we'll enter the variables after this, so int min and int max. And a semicolon, of course. So now the first d will be assigned to the int min and the second one to int max. And now if we run this, then let's see what the range of values is for the integers. So and we see that the range goes from this number to this number. So we cannot count higher than this number. So you have to keep this in mind, especially when you are working with large data sets. But okay, back to the variables. So let's just delete this again. What you also should know is that there are signed and unsigned ints. So if we enter signed prior to the int here, then this means that there's might be an integer with a sign in front. But if we type in unsigned, then this is definitely not a negative value, but this would cause problems if we then try to set x as a negative value. So if we try to enter -4 here and then try to output this with a cout command, then you see that this results in a large number, which is definitely not a -4. So back to +4 here, and so this is just the right number again. Okay, so this should be enough for this. So we have finished the data type int now, and therefore let's just set this block as a comment. And because I set this as a comment, I can now remove this block, these 4 lines. Okay, and now let's concentrate on the next data type, which should be float. Because with floats we can say floating points numbers. So for example, we set a float number a and assign a value, for example, let's just say 1.9. And we can also set another float value, let's say float b, and this should be 9.4, just any random floating point number. And now we can compute a plus b in the output. And let's just see, this is the result. Now we can also try to add more decimal places. So this then just set any numbers behind the floating point and compute this in the output, and you see that this is also no problem. So this is one possibility to handle floating point numbers, and here also there are signed and unsigned floats. For example, an application would be that you want to compute the surface area, and it would be clear that the result cannot be negative. So this is done as well. So let's comment this out again and remove the block. The next variable is double, and doubles also are for floating point numbers, but the difference to float is the range, so the codomain. Because with doubles you can get a higher accuracy at a higher range of values. If you're interested in this, you can read this on the internet, but because there are also differences in different systems. But you should just remember that with doubles you get a higher accuracy and a bigger range of values. And here also we type in double, and then let's just set a variable, for example pi, and pi equals roughly 3.14159, and then just check that this works by creating an output. So let's run this, and you see that the output works and the double is working, which leads us to constants, because you can handle constants in C++, for example, by setting the keyword const in front of a double. So here, this means that pi now cannot be changed. I want to show you this by just okay, first run this to see that this still works. But if we now want to change pi by just setting it to, let's say, 1.1234, then you see that this results in an error, which says here, okay, this is a constant and this cannot be changed. And this is due to the fact that we set the pi as a constant, which is just per definition not allowed to be changed. So this is one possibility to handle constants. Another one is to define it in the header already. So for this we just type in with the hash key define and then pi, and set this to 3.1415. And this now says that at any place where pi shows up in the code below, then please exchange pi to this number. And I'm gonna try this right now. So if I type in pi here for the output and run the program, then you see that the compiler outputs 3.1415. So now we have finished the subject of doubles. I'm just going to comment this for constant again. And the next topic we are going to talk about is characters, chars. So I said it in the beginning, with characters we can handle letters, for example. It can be useful for inputs when the user, for example, should type in something or choose something from the dialog window or within the console, and if the user should confirm something, or for example if the question is if the program should continue or stop, then you can make an if condition so that if the input is the Y key, for example, then please continue the program, or if it is the N key, then stop the program. So just as usual, we are going to type in the data type, followed by the name of the variable that we want to assign, and then the letter that our alpha should be assigned to, in which case I just choose A. So now it is clear that the character alpha is assigned to an A. And just like this, we are going to do the same thing with beta. So, and don't forget the inverted commas here. And we're doing this a third time for T, maybe. This one's a C. And now we can put this in the output. So if we type in alpha, then an A shows up, and we can add our other letters too. So let's put B in the output and also our T, which then is a C, and look how it looks like. So this is ABC, just as we typed it in. So now we are finished with our characters, so let's just comment this out and let's go to the next data type, which is a string. So, and in contrast to characters, which just save one specific letter, with strings we now can save a string of letters, so just a chain of different letters. And this is useful especially if we are working with files, because if we want to import files or write something into some files or even create files, we always have to save the file name or the path into a string in order to access the file or to the path we want to save a file into. So just as usual again, we're typing in the data type name, and in this example I just want to type in a prename. So prename and then inverted commas again, and you just put in the name. But this won't work until now. You can see this if I just want to output the prename and run this, then you see there's an error. And this is because we first have to include as our string. So just type in hash key include and then string. And now this should work. So if I execute this again, then you see the prename. So that's it for strings. We can now comment this out again, and let's move on to the last data type, which is Boolean. So with Booleans we can save true or false answers, and this is often applied if there's a decision to make. So for example, there's an if condition and it says if the input is like this, then do this and put this Boolean to true or false. And this input could be that the user has to decide something. And therefore we are just going to type in now our variable name bool choose is going to be set to true. So this means our choose variable is now set to true, and we can work with this now. So for example, we can make an if condition. So if, now type in the condition, which is choose is true. And here you have to be careful because you have to type in two equal signs, and this is only for the inquire situation, because if you want to assign, like in here, so there is an assignment, choose is set to true, then you only have to use one equal sign, but in the if condition you have to use two. So, and after the if condition, if that's true, then the block now will be executed. So we're going to type here cout true end line, and now if that's true, then the output will come. And for any other case, well, we only have two cases, but we are going to fetch that with an else condition. So else, and this is the case if choose is false. So that's why we are going to type in here cout and false end line. And now if we run this, then you see that choose is set to true, and it should be the output true, just as we wrote it in this line. So let's see what happens if we run. So, and you see the output is true, just as expected. Okay, we can now also change this Boolean to false and see then the output is false. To see what happens exactly, we can insert a so-called breakpoint and start debugging with F5 and see what happens in the debugger. And now the program runs to the breakpoint and stops here. So, and now we can look what happens step by step by clicking on this button here. And that's what we are going to do. So let's try this out. You see that we now have reached the if condition, which is in this line, and if we click one further, then you see that he jumps right over this cout command to this one right here, because the if condition is not valid. So, and then you see that in the console there's written false. So now we reached the end, but we can look at it once again if we change our Boolean to true. So like this again, and then run, and we reached our breakpoint now. And if we click the button, let's first see in the console there's nothing right now, but if we click one step further, then we again are in the if condition, and still there's nothing in the console. But last time it jumped right over to the else condition, and now it goes into the if condition because now the condition is true. So what he does is now writing true into the console. And the else condition is not considered, and he just jumps to the end of the program. So now we are finished with our booleans, and we can delete the breakpoint. So right click on it, delete breakpoint, and we can comment this out. And so that's it for this time. I hope you got to know all the data types briefly, but my recommendation is to look at it more in detail, take your time and see all the data types again. So that's it for this time, and see you in the next video.